Okay, so now let's learn how to balance chemical reactions. So there are a few steps that we need to follow here. In order to balance a reaction, you need to have an equation with all the chemical formulas written correctly. Okay, you have to see how many of each element you have on both sides of the equation. We are going to write coefficients in front of these compounds or elements until the total count is the same on both sides, okay? So we basically have to multiply to get to a certain number. I'm going to show you how to do that with these simple examples right here, okay? There are several ways that you could do this. You can count it and write it down. You could do it in your head. You could write little side notes, sort of up to your style, okay? So I'm going to show you a couple different styles here, but you can definitely come up with your own. See this arrow here? This reaction arrow tells you that whatever's on the left, this is your reactants, has to equal whatever's on your right, which are your products, okay? So what some people do is they'll write the available elements down this arrow. So for example, there's a sulfur and there's an oxygen. So they'll write an S and they'll write an O, and then you'll have the same sulfur and oxygen on the right-hand side. Obviously they look different, but same elements, okay? Then you can count to see how much you have in the moment, okay? So for example, I have 8 sulfurs. So I put an 8 here, and then I have 2 oxygens, so I put a 2 right here. Then I count the right-hand side. How many sulfurs do I have here? Well, there's no number, so that implies a 1. Then how many oxygens do I have here? 3. Then you ask yourself, is this conservation of mass? Do I have the same number of elements on both sides? The answer is no. So then you have to put coefficients to make them equal. So let's look at this first option here, okay? Right here, you want your sulfurs to be equal. So you can't go down in number. You can't just subtract off, right, elements. So you only can go up. And the only way you can go up is multiply going up. You cannot add, okay? Only multiply. So when you see these coefficients here, you got to imagine that there's a multiplication symbol here. The multiplication symbol is not actually there, but we put it there just so that it reminds you to multiply. So you're going to ask yourself, like, what number should go in here that multiplies by this imaginary 1 that will get me to 8, right? So what times 1 equals 8? Then most of you would say 8 times 1 gets me to 8. So I don't have any 1 anymore. I now have 8, right? So now that I have 8, right, this is now equal. We're good. But check out what you just did. When you wrote an 8 here, okay, you changed this sulfur, but you have to always check what other elements you are changing. So 8 times 3 here, right, 8 times 3 is 24. So you don't have 3 oxygens anymore. You now have 24 oxygens, right? So now you're thinking, okay, my oxygens are not balanced. I have 2 on the left-hand side of the arrow, but I have 24 on the right. So how can 2 become 24? What number am I going to multiply with? So what number should go here multiplied by 2 that gets me to 24? So you're like, what times 2 equals 24? You can think about backwards, right? 24 divided by 2 is 12, right? So now you do a quick check. I have 8 sulfurs on both sides, and I have 24 oxygens on both sides, so now it's balanced. So some people ask, well, what about here? You can leave it blank, but if it bothers you, then what number is always implied when it's blank? A 1. So you can leave it blank, or you can put a 1. Either or, it doesn't matter. Now, for some of you, doing all that counting is like complicated. You're like, I don't want to write anything. So if you don't want to, you don't have to, okay? So let me just show you an example of where you're just doing it in your head, okay? So here's the arrow. That's where you always want to check. So everything on the left has to equal everything that's on the right. So you do a quick check. You have 2 oxygens on the left, but you have 3 oxygens on the right. You're like, oh, that is not equal. You know your only option is to multiply going up. So you can't just add 1. That doesn't make sense, right? So 2 and 3 can both multiply up to what number? Like most common factor here, right? 2 and 3 can multiply up to the same number, which is what? 6, right? So you want 6 of each one. So what number times 2 will get me to 6? So you're like 3 times 2 gets me to 6. So I now have 6 oxygens on the left. So what number times 3 will get me to 6? And you're like 2, okay? So you can make like scratch notes, like, you know, notes to yourself here. You're like, okay, I have 6 total oxygens. I have 6 total oxygens. Good, right? But the coefficients are 3 on the left and 2 on the right. Now, remember that when you put a coefficient, you always have to check to see if it affects any other elements. So you're like, oh, this 2 has to multiply by this 2. So how many irons do I have? 2 times 2 is 4. So you're like, okay, I have 4 irons. Over here, I only have 1. So what number times 1 gets me to 4? 4. So if you want to work it that way, you can just do it mentally here. You're like, okay, I have 4 irons on both sides. I have 6 oxygens on both sides. Okay. So once again, I'll show you another example where I write out all the work and another example where you're sort of doing it in your head. So you can do what you want here. So here we go. If you have arrow here, this is where the left has to equal the right, reactants equals products. You check to see what elements you have. So I have a hydrogen and I have an oxygen. So I'm going to do a quick count. I have 2 hydrogens on the left. I have 2 hydrogens on the right. I have only 1 oxygen on the left, but I have 2 oxygens on the right. So you're like, oh man, not balanced. Have to balance it out. So my oxygens are not balanced. So you got to fix this first. This 1 needs to be multiplied up to a 2. So total of 2 is my goal. So you always think to yourself, okay, what number times 1 gets me to 2? And it would be 2. 2 times 1 is 2. So 2 times 1 equals these numbers down here, which is the 2. Now remember that every time you put a coefficient here, you got to ask yourself, did I affect any other elements? So 2 times 2 is what? I don't have 2 hydrogens anymore. I now have 4. Okay, so I have 4 hydrogens that I need to deal with. So now it's not equal. So now my goal is I don't need 2 hydrogens. I need a total, right? Total of 4. So you have to ask yourself, what number on the right-hand side times this 2 will equal 4 over here? Okay, so what number times 2 equals 4? So you're like, 2 times 2 equals 4. So then what's the answer? It's 2, 2, and right here you can leave it blank, or you can put a 1. Okay, and that's how you would do it if you want to write out all your work. Okay, one more example if you're just doing this inside your head here. All right, so you just sort of think about it, like, okay, I see that I have 1 K on both sides, equal. 1 chlorine on both sides, equal. Oh, but my oxygens, I have a 3 here and I have a 2 here. Oh, it's that one where it's not the same. So like, okay, I can't add, I cannot add, so I have to multiply going up. Both of them have to get multiplied up to the same number. Okay, then what's my goal number? My goal number, you can write it down or you don't have to, is 3 and 2 both multiply up to what? 6. So 6 is sort of like my scratch work here. My goal is to get to 6. So what number, right, times 3 is going to get me to 6? What number times 2 is going to get me to 6? So I'm going to put a 2 here. 2 times 3 is 6. I'm going to put a 3 over here. 3 times 2 is 6. Now, putting a number over here, this 3 doesn't change any other element, so I'm good here. But putting this 2 here affects other elements. When I put a 2 here, I now have 2 Ks, potassium, and I now have 2 chlorines. A coefficient affects every number in the compound, right? So now I have 2 Ks and 2 chlorines I need to worry about. But over here, I see that I only have 1 of each. But if my goal is 2 of each, right, then what number do I need to put here to multiply by each of these to get 2 instead? Then you would be like, oh, I need to put 2 here because 2 times 1 is 2. 2 times 1 is 2. So what is the answer to this problem? It's 2, 2, 3. Some of you, like I said, can do all of it in your head. Great. Okay. If not, I highly recommend writing it out and counting it out. All right, we'll do some more practice. Okay, so now let's do some more complex balancing problems. So once again, I'm going to do examples of where I'll show my work and others examples where I don't. So here we go. Here you have more elements that you need to think of. This is where your yield arrow is. So this is where I'm going to write all my elements here. I have a magnesium, which is Mg. I have a manganese, which is Mn. I have an oxygen, which is the letter O. Now I can count. On the left-hand side here, I have only one magnesium. I have 2 manganese, and I have 3 oxygens. Then on the right-hand side, I have 1 magnesium, 1 oxygen, and 1 manganese. So only one of each of these elements on the right-hand side. You can already tell that it's not balanced, so I have to change the numbers and balance the reaction. So here, I need my manganese to go up, right? And I also need my oxygens to go up, okay? So I'm gonna go ahead and focus on this manganese. I need to think about what number needs to go in this box. So if I multiply by this number, it equals, what am I gonna change it to? A 2. I need to multiply up to a 2. So what times 1 gets me to a 2? The answer is 2. 2 times 1 is 2. So now these are all balanced. Now I'm gonna focus on my oxygen. So here, I have an oxygen on the right-hand side that is not balanced, so I have to find the oxygen on the right-hand side. What number do I multiply this 1 by so that this 1 can get multiplied up to a 3? Okay, so 3 times 1 gets me to a 3. So now this side is good, except when you have a compound here and you have a coefficient, you also now change how many magnesiums you have. 3 times 1 magnesium is now 3 magnesium. So now you change the number of magnesium. It's very important that every time you write a coefficient, you always check to see if you affected other elements. So now my magnesiums are unbalanced. This one on the left-hand side now must be changed to a 3. So I got to think, what number am I going to multiply 1 by so that it equals what? The 3 here. What times 1 equals 3? The answer is 3. So the answer here is 3 blank 3 2. And if you want to, you can put a 1 right here. Okay. So then a next problem down here. Okay. So if you want to do it in your head, you got to think, okay, I have zinc, I have a hydrogen, I have a chlorine on the left, same thing on the right. So now I look for like unmatching numbers. So I look here, I'm like, okay, I have 2 chlorines on the right, only 1 chlorine on the left. So I have to put what? What times 1 gets me to a 2 on the right? So I put 2 here. So 2 times 1 gets me to 2. That's equal, but putting a coefficient here has changed this hydrogen. So now I have 2 hydrogens on the left, and how many hydrogens on the right? 2. That works out. So you do another quick check. I have 1 zinc on each side. I have 2 hydrogens on each side. I now have 2 chlorines on each side. And now this is already done. So it's blank 2 blank blank, or you can always throw in some 1s if you would like. Okay, not mandatory, right? So now let's get to even more complex problems. So here we have even more elements. A piece of advice that I have for you in this moment is that if you have 3 or more capital letters, that means you have a polyatomic. And when you have a polyatomic, it's a good idea to put parentheses around them. So you're like, wait a second, I don't remember what polyatomics are. Remember, they're in the back of your book. Let's take a peek. So right here, we have 3 capital letters, AgNO3. So there is a polyatomic here. If you recall, the NO3 is right here. Right? So NO3 is our nitrate polyatomic. Not that you need to really know the name, but it's a good idea to put parentheses around polyatomics. Why? Because instead of breaking apart the polyatomics, it's easier to just keep the polyatomics together and find the matching polyatomic on both sides of the equation. So there's an NO3 on the left, there must be an NO3 on the right, okay? Not like 100% of the time, but like 99% of the time, there's always a matching polyatomic. So there's NO3s on both sides. Here's another one where there are 3 capital letters, LiOH. So LiOH, you take a peek, you're like, okay, where is this polyatomic? There's an OH here. So that means we're going to put parentheses around the OH. So let's put parentheses around this OH, and then there should be a matching OH on this side. So now when you count, okay, you are now counting elements and polyatomics. So if you were to show your work under this arrow here, remember it's like your equal sign. I have a silver, Ag. I have the polyatomic NO3. I have lithium, and I also have the polyatomic OH, hydroxide. So I'm going to do a quick count. I have 1 silver. Now, NO3, right? Do you see how 3 is on the inside of the parentheses? So you always look on the outside to see what number you have. So here, I have only 1 nitrate because 3 is on the inside. That's part of the polyatomic. So I only have 1 nitrate. I have 1 lithium. Once again, OH, you look at the number on the outside. I only have 1 here. So for silver here, I have 1 silver, 1 hydroxide. I have 1 lithium, and you always look at the number on the outside. It's a 1. So 1 lithium and 1 nitrate. I have 1 of everything. It's already balanced. So you don't have to do anything. Already balanced. So you can leave it all blank. Or if you want to give like a mental note to yourself, you're like, these are already balanced. These are all 1s. 1, 1, 1, 1. Okay. So now same thing over here, right? You are going to then look for your polyatomics, okay? Just a little, so this only has 2 capital letters, so no polyatomic. This one already has a parenthesis, so you know that there's a polyatomic there. There should be a matching PO4, see this PO4 here, on the right-hand side, which is here. Da, 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 da. And then this one only has 2 capital letters, so nothing to be concerned about there. So now you do your mental count here, okay? So we try to see what's not the same, right? Like for instance, you have 3 berylliums here, but how many berylliums on this side? Only 1. So what number should I put here to multiply by this 1 to get to 3 that I need so that they're equal? Well, I'm going to put a 3 here because 3 times 1, this is the arrow, 3 times 1 is 3. Now, when you put a coefficient here, you always check what number did I change. I now have how many chlorines? 3 times 2 is now 6 chlorines. I need 6. I have 3. So what number should I put here? What times 3 gets me to 6, right? You're like 2. 2 times 3 gets me to 6. Okay, perfect. Then you check to see how it affects your other elements. I now have how many Fe's, which is iron. 2 times 1 is 2. So I have 2 irons. So now you're like, okay, I have 2 irons. I'm going to look on the other side. What times my 1 iron gets me to 2 irons? 2. 2 times 1 is 2. When you put a coefficient here, you got to think, how else did I affect this polyatomic? Remember, the 4 in PO4 is on the inside. Okay, so you ignore that number 4. You got to think, how many PO4s do I have? I now have 2 because 2 times 1 is 2. Then you look on this side, you're like, how many PO4s do I have on the left? I already have 2. See how 2 is on the outside of the parentheses? Then it's balanced. So now the answer is 2 blank 3 2 or 2 1 3 2. Okay, however you want to write it. Okay. I'm going to go ahead and skip this last one real quick. And now I'm going to go to these ones down here. Okay, so now these equations are very special because, and you should be able to spot them very easily because we call them the Cho equations. Cho, because the only elements that exist here are C's, H's, and O's, carbons, hydrogens, and oxygens. Okay, they don't have polyatomics. It's just a Cho equation. So when you first look at an equation, I highly recommend like determining if it's a Cho equation. So you look at this and you're like, okay, I see C's, I see H's and O's. It's Cho. It's a Cho equation. So for this first one, I'm going to write this down, a Cho equation. When it is a Cho equation, I highly recommend balancing in the Cho order. So C's first, then H's, then O's. Okay, so let's do your carbons first. Your carbons, right, you have 4 on the left, and then you have 1 on the right. So Cho equations are the only ones I want you to do a little bit differently, like focus on each letter at a time. So just do your C's. So this is unbalanced. This one needs to become a 4. So you got to ask yourself, what number times 1 gets me to a 4? Like, okay, 4. So 4 times 1 gets me to a 4, but we'll focus on these oxygens in just a second. So now your carbons are balanced. Great. Then what are we going to focus on? Your H's. So let's look at your H's. Your H's are, you have 8 on the left. But how many H's do you have on the right? I only have 2. So you're like, hey, this 2 needs to become an 8. So you ask yourself, what number times 2 gets me to 8? Okay, no adding. You have to multiply. What times 2 gets me to 8? 4, right? 4 times 2 is 8. Okay, now our H's are balanced. Now we got to move on from there. So now you take a peek here. I have 2 oxygens on the left. Now, what's special about the Cho equation is that the oxygens are split. You have oxygens on here, this, and you have an oxygen over here. So then you have to add those oxygens up. So multiply, then add those together. So for example, 4 times this 2 is how many oxygens? 8. And then plus 4 times 1, right, is 4. So what is 8 plus 4? 12. Okay, so that's how many total oxygens I have on the right-hand side of my reaction. Now you see it, that it's unbalanced, so now it's your job to balance them. 2 needs to become 12. What number times 2 gets me to 12? 2 times 6. So the answer here is 1644 or blank 644. Okay, let's do that one more time. Let's do another Cho equation. So once again, start with your C's. Okay, and if you don't want to do scratch work, you don't have to. So you have 2 here, you have 1 here. So what number needs to go here? Good, 2. 2 times 1 is 2. C's are done. Boop. Okay, and then let's do your H's. You have 4 on the left, but you have 2 on the right. So this 2 needs to become a 4. 2 times 2 is 4. So now your H's are done. Yay! Now let's focus on our O's. You have 2 on the left, and now you have to add these. So I would do some scratch work here. 2 times 2 is 4, right? Plus 2 times 1 is 2. 4 plus 2 is 6. This 2 needs to become a 6. So what number goes right here? 3, because 3 times 2 is 6. You could put a 1 here or not. It's up to you. We're going to skip these bottom 2. Boop, boop. Okay, save them for a rainy day. But that's how you do your Cho equations. We'll do more practice in class. So yay!